So welcome to our lesson on an equation of a tangent line. We've done bits and pieces of this here and there. Here's a little joke for you. Your tan line is showing. So remember that tangent from geometry is where you have a function like this and your tangent line crosses at exactly one point. It shows the slope at that point, okay? So for example, on that note, if I have a function that looks something like this, what I could do is I could find the tangent of a function at any specific point. And the reason why I choose points is because here, right, my tangent line is positive. Here, my tangent line or my slope is 0. Here, it's negative, right? It's decreasing. Over here, it's positive, right? So my tangent, my slope changes depending on where the point on the graph is, okay? So how do you find the equation of a tangent line? Here are some steps. I do have this written for you. First thing we want to do is find the derivative of the general function. That'll give us what the slope is. You take the slope and you plug it in, to the formula y equals mx plus c, which is the equation of a line. And then you take your x and your y and you just plug it in to find out what that c is. Okay, so let's go ahead and try an actual problem. So this will help us out. So if I have this is a very famous equation, y equals x squared, looks something like that, right? Something like that. And we're looking for the point x equals 2. That's critical. So if I were to go ahead and graph this, if I say 1, 2, and then this point right here would be, right, to find out what that point is, I want to go ahead and set my x and y, do a little table. I know x is equal to 2, y is equal to x squared, so 2 squared gives me 4. Okay, so when x equals 2, y is equal to 4. Okay, so now I want to find the line that is tangent to this. So let me just go ahead and do my best with drawing a tangent line. So let me just go ahead and make some inferences right here, right? So this line right here, the tangent line, should be a positive number. My y-intercept of this line should be a negative number. Okay, so that's what I should get when I have my actual equation done. So the first thing we want to do, step 1, is we want to find the derivative of the function. So we have f of x is equal to x squared. So f prime of x is going to equal, right? Let's find the derivative. 2 times 1 is 2. Put the x down. 2 minus 1 is 1. Okay, that 1 is right there. It's an imaginary number. So if I were to go ahead and plug in my number, which is x is equal to 2, I know that f prime of 2 is equal to 2 times 2, which is equal to 4. So my slope is 4. Okay, so good. So now I know that. The next thing I want to do is, after I find the derivative of a point, find the derivative of the second point, which I did, and I found m, and now I'm going to go ahead and use my equation, right? So my equation is y equals mx plus c. Usually some people say b. That's like in algebra. So we know that our m is equal to 4, and we know our point is 2 comma 4. So wherever I see my y, right, I'm going to plug in the number 4. So I have 4 is equal to, my m is 4, right? I just found that in step 1. So 4 times my x is 2. So I'm going to put my 2 there, and I'm looking for what my c is. So 4 times 2 is 8, plus c is equal to 4. Subtract 8 from both sides. So this cancels out. So I have negative 4 is equal to c. So now let's put the whole thing together. So step 3, y equals mx plus c. I know that my y, right, is just going to stay y. My slope is 4, so I'm going to plug that 4 in, x, and my c is negative 4. Okay. I can do this on the calculator. Let me just go ahead and just show you how to do that real quick. My calculator will turn on. Let me just clear it. All right, so first thing I want to do is I want to go to my y equals, and I want to put in my original function, y equals x squared. Okay, so you're going to have to hit graph next. And when you hit graph, it'll show you what the function looked like. And then the next thing we can do is, you see this draw button right here? So to get to it, it's in blue. So I hit second blue. and I'm going to do option number 5, which is tangent. So number 5. And now here I want to find this at x equals 2. So I'm just going to put the number 2 in and I hit enter. And my calculator will also give me, boom, there's the function, y equals 4x plus -4, which is exactly what we have here. Okay, which again, intuitively, this should make sense, right? My slope is positive and my y-intercept is -4. Okay, all right. So that's the steps on the calculator. Let's go ahead and try another problem, right? So now this one right here, why am I teaching you how to do this by hand? Because in this case, anytime it asks us to find k, it's not going to be as straightforward, okay? So for this question right here, it tells us that the point is 1, 5, so my x is 1, my y is 5. It also tells us the equation of the tangent line of f of x at point P is y equals 3x plus 2. So why are they giving us this, right? They're giving us this because they want to tell us that the m is equal to 3, okay? The slope is equal to 3. This is the same thing as f prime of x, right? Slope is derivative, okay? All right, so since I said the word derivative, because I have the slope, right? Let's find the derivative of this function. So I have f prime of x is equal to 2 times k x, right? And then 2 minus 1 is equal to 1, plus the derivative of x to the first, 1 times x is 1, and then x to the 0 power goes away, okay? So now I have this function right here. I do want to find it at the point where x is equal to 1. So all I'm going to do is now plug in f prime of the number, which is better. 1 is equal to 2k times 1 plus 1. So let's simplify that. 2 times 1 is equal to 2k plus 1, right? So we already know that f of x is equal to 3. So what I'm going to do here is, let me just go ahead and let's go green, okay? So I'm going to take this function that I have right now, which is 2k plus 1, right? And we're going to set it equal to the slope or the gradient, which is equal to 3 to find out what k is. So minus 1 from both sides, cancels out. So I'm left with 2k is equal to 2. Divide both sides by 2, and I get, boom, k is equal to 1. Celebration. Okay. Next part of the lesson is equation of a normal line. All right, so I just went ahead and added a graph for an equation. So this right here, let's just call this f of x. So normal is a line that is perpendicular to the tangent line. So we already know what tangent line is, right? So tangent line at, let's just say this point, I'm going to draw this as best as I can. Okay, so there is an example of a tangent line, right? Crosses at exactly 1 point. So now to draw the normal line, let me just go ahead and do this green. I'm looking for a line. Remember, a normal is the line that is perpendicular. So let's refresh our memory about what perpendicular means, right? So if I have a line that looks like this, the line that is perpendicular is going to look something like this, right? It's going to be 90-degree angles with the line that I have. So let's go ahead and do that here, right? So let's make a 90-degree angle at this point right here. So the normal line would look something like this, which would make 90-degree angles right there. Okay, so it's not so bad. We just need to add one extra step. Okay, so here are our functions, or here are our rules that we're going to do, are the steps. So we're still finding the derivative, right? We're still finding the derivative at a specific point like we did before. And we're going to use, like, instead of just saying all of this, I would just say, like, we're going to use negative reciprocals of each other, right? So the negative reciprocal of 2 is -1/2, right? Why? Because if there's no denominator, there's an imaginary 1. So we're going to flip this and we're going to make it negative, okay? The negative reciprocal of -1/4. When we do that, right, negative negative becomes a positive. 4/1 switched, or reciprocal of that is just going to be 4. Okay, negative reciprocal of -3/2 is going to be +2/3. Okay, So that's the third line, the third step that we're going to be doing here, and we're still plugging it into the function y equals mx plus c, except we're using our negative reciprocal slope instead of our regular slope, okay? So we're going to go ahead and do a question. All right, so what might a problem look like this? Just be sure. All right, so over here we have a point. X is 1 and y is equal to -7. So x is equal to 1 and y is equal to -7. We have a function. So we know step 1 is going to be find the derivative of this function. Okay, so we have f prime of x is equal to, right? 3 times 2 is 6. X, 3 minus 1 is 2. Should be able to find the derivative quite straightforward here. 1 times -4 is -4. And then we have the x, 1 minus 1 is equal to 0. And this goes away. Okay, so there's my derivative. We know that x is equal to 1, so I'm finding the derivative at 1. So let's go ahead and plug that in. 6 times 1 squared minus 4. So this is going to be 1 squared is 1 times 6 is 6 minus 4 is equal to 2. Okay, so that means that my slope is equal to 2. Now I have all I need to plug it into the function, which is y equals mx plus c, right? Before I can do that, because I'm looking for the equation of the normal, not the tangent line. So to do that, I'm going to go ahead and take this number and make this into a negative reciprocal. So the negative reciprocal of 2, right? Let's call this m2 is equal to -1/2. So this is what gets plugged into my m, right? I can call this m2. So I have my function right here, right? I have my point, which is x equals 1, y equals -7. So let's use that, right? Y equals -7. So let's plug that in here. Is equal to my m2 is -1/2. So let me put that down. My x is equal to 1 plus c. Okay. So now let's go ahead and solve this. So when I solve this, -1/2 times 1 is equal to -1/2. Plus c is equal to -7. We add 1/2 to both sides. Add 1/2 to both sides, right? The calculator can give us this. So I have my calculator. I have -7 plus 1/2, right? So alpha y equals option number 1, 1/2. Hit enter, and I get -13/2. So I get c is equal to -13/2. And now let's go ahead and put everything together. So I have y is equal to, my m is -1/2 x plus c, which is -13/2. So -13/2. This is the equation of my normal line, right? Let's go ahead and get into some practice problems. So you can tell that this one is a 20-pointer. So the reason why I'm doing this, yes, I kind of beasted a little bit just to start us off. And that is because, and then the rest of them is a little bit less. But this is a good point to kind of just go through and review everything that we've done so far. Okay. All right, so we're going to start out with something calm, right? Find f prime of x of this function right here. So let's just go ahead and rewrite f of x. So f of x is equal to 2, and then when I take this x squared and I kick it up to the top, that becomes a -2, right? Minus ax. So I'm going to find the derivative of this function right here. -2 times 2 is equal to -4x, and then I take this exponent, subtract 1 from it, so that's going to give us -3. Perfect. And then I have minus, and the derivative of -ax is just -a, right? There's an imaginary 1 here. 1 times -a is -a. 1 minus 1 is 0, so that x to the 0 is just 1, okay? So I have my derivative right here. If I wanted to take this and write this a little bit differently, you wouldn't have to, but if you wanted to, you could write -4 over, and this is x to the -3rd. We can kick it to the bottom, and then this is going to be minus a, okay? Boop, done. For the next one, it says the function f of x has a local min. So since the function has a local minimum at x equals 2, what that is teaching me is that f prime of -2, right, the derivative at -2 is equal to 0. Remember from our last lesson, right? If we have a minimum, the slope or the tangent of that line is equal to 0. So the next thing that we want to do is we want to take our function right here and we want to plug in -2 in for our x. Okay. So here it says show that a is equal to 1/2. So let's do that, right? We have -4 over, instead of x here, I'm going to plug in -2, raised to the third power, minus a, and we have this equal to 0. So let's go ahead and solve this. I can add a to both sides, plus a plus a. So do that, and I get, just for sake of space, I'm going to get a is equal to, I like writing the letter first, and this is something that I can plug into my calculator, and when I do that, I get a is equal to 1/2. Okay. Point C, find the y coordinate. So we have completed the function. Since we know that the function has a local min at x equals -2, right? They told us that. We're going to substitute x equals -2 into f of x. Okay, so we have over here, we have y is equal to f of -2. So we're going to go ahead and plug in -2 into the original function, okay, which is over here. Yep. So I'm going to plug -2 right into there. And so to do that, I have y is equal to, and I'm going to do 2 over -2 raised to the second power minus, and now I know that my a is equal to 1/2, so I can plug in my 1/2 here, and I'm going to multiply this by -2, right, because my x is -2. So take this whole thing, plug it into the calculator, and you're going to get y is equal to 1.5. You could have 3/2 as well, but this right here is going to be our answer for C. That's our y coordinate. For part D, I know we're running out of space. For part D, we're just going to go ahead and sketch the graph of f of x. So let me just grab my calculator. All right, so I went ahead and plugged in my original function, except instead of the a, I found out that a is 1/2. So I plugged 1/2 in, so 2 over x squared, right? I'm just plugging this part in. Minus by a is 1/2, so I put 1/2 x. And then I went ahead and hit graph. They want us to graph it over a specific interval, so I'm going to go ahead, go to window. My x, they want it to be between -5 and 6. They're so demanding. And then my y's, they want it to be between -3 and 6. Oh, what the quarantine? -3 and 6. Okay. And then I'm going to go ahead and hit graph. And here is what my graph is going to look like. So for the next part, which is part D, I just need to sketch this, okay? Y'all can sketch. State the values of x for which f of x is increasing. We did this last week. Increasing means that it's going up, right? So right from here up, looks like this might be -2. Let's go ahead and confirm that. So second calc, I'm looking for my minimum, which is option number 3. I'm going to go to the left. Okay. Okay, I'm going to go to the right. I And now I'm gonna go to, oh crap, minimum. Okay, so it gives me that the minimum is -2. So I know it's going to be decreasing from -2 x up until 0, because at that point is where the graph goes up, and then over here there's like a, it's called an asymptote. Okay, it doesn't cross that. So let's do the next part. The next part says find the x-intercept of the graph of the function. The easiest way that I know how to do that is I go to y, go to my y2, just put 0 right there, and then when I hit graph, I'm going to look to see where these 2 points, where they meet. So to do that, I hit second calc. Option number 5 is intersection. At this point, I would hope that this is kind of like second nature to us. Then you just hit enter, 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 and it gives you the intersection, right? So 1.59 to 3 significant figures, right? 1.59 comma 0 is our intercept. All right, so now we're calculating f prime of 2, right? We already know f prime of 2 is going to, well, f prime of x, we found that out, right? Over here somewhere. So all that stuff. So -4 over x to the third minus a, which we found out was 1/2. So I'm plugging in 2 here. So this is going to equal -4 over 2 to the third power minus 1/2. Take that, plug that into the calculator, and you're going to get -1. Okay, you can plug that into the calculator. And now here's our question. Find the equation of the normal. Okay, so to do this, remember that we have to find the negative reciprocal of our slope. So our slope is equal to, if I look over here, right? If I look over here, we just got f prime at 2, which is what they want us to find the normal at, is equal to -1. So m is equal to -1. Okay, so if we're finding the normal, we're finding the negative reciprocal of this. So m2 is going to equal the negative reciprocal of -1, which is just +1. I was just going to write a positive, but I don't need to. So our slope is going to equal 1. So now we need to find the coordinates of f of x at 2. So if x is equal to 2, what is y? And we have to go back to our original function for that. So if I plug 2 in for my x right here, my y, and I know my a is equal to 1/2, then my y is going to equal -1/2. -1/2. So there's my x, there's my y, and now I'm going to go ahead and plug this together, right? Y is equal to mx plus c. So I know that my m, my new normal, is going to be 1. So I have y is equal to 1x plus c. Here's my coordinate, right? Y is -1/2. So I put -1/2 in, is equal to 1 times 2, which is 2 plus c. And I have to figure out what my c is. So to do that, I just go subtract 2 from both sides, subtract 2, and I get c is equal to, right, magically, the calculator does it, right? It's going to be -5 over 2. Again, please do this yourself. Make sure that you are comfortable with all of this. And the last thing we're going to do is put it all together. So I have y is equal to, my m is 1, so I have 1x, which is just x, and my slope, sorry, my y-intercept for my c is -5 over 2. All right, so this is the equation of my normal. That was 20 points, boys and girls, people. Question number 2, okay? So we're gonna go ahead and we have a car driving over a hill, da-da-da. So find the gradient of the hill at the point where x equals 2. So I could use my calculator like I showed you earlier on, or I can explain it to you by hand. So the first thing we want to do is we want to find the derivative of f prime of x. So 2 times negative 1/4. If you do that in the calculator, that's going to give you negative 1/2. And this is going to be x. The 5 is by itself, so that's going to go away. So here's my derivative. I'm going to go ahead and plug in, since I want to find the gradient at x equals 2, I'm going to plug 2 in here for the x. So I have negative 1/2 times 2, which is equal to negative 1. Okay, so the gradient of the hill at 2 is negative 1. Next part. So P is the value of the point where the gradient perpendicular to the hill is equal to 3/2. All right, so for these 3 points, right, for the next one, all you have to do is, it says perpendicular, so as soon as it says that, we're going to take this gradient and we're going to find the negative reciprocal of it. So m2 is, right, the negative reciprocal of 3/2 is negative 2/3. Interesting how in the example problems above, this is what I did 3/2. All right, so now they are asking us to find the x value. So we know that the derivative, let me just go ahead and change the color. We already know that the derivative is negative 1/2 x. So we're looking to find this x value when our slope is negative 2/3. So I have negative 1/2 because that's our gradient. We're looking for our x, and we're looking to see what our x is when our slope is negative 2/3. So I want to go ahead and solve for x to get this. This is multiplication. To get this away and to get the x by itself, I'm going to divide both sides by negative 1/2. Divide this side by negative 1/2. And magically, when I plug that into my calculator, I get 4/3. So x is equal to 4/3. Okay, that's my x value. All right, 2 questions done. First step here, find the derivative. This should be automatic. 4 times 2 is 8x to the third. This is a constant, so that just goes away. Find the gradient of the graph at x equals negative 1, right? So I just found the derivative, so all I'm going to do is I'm going to plug negative 1 in for x. So I have 8 times negative 1 to the third power, which is equal to negative 8. This was an easy 3 points. Okay. Next one, find the x coordinate of the point, right? So now we have to find the, at the point which is normal to the graph. And it says it has a gradient of negative 8. So to find the m2, just like we did above, we are going to find the negative reciprocal of negative 1/8, which is positive 1/8. And then the next thing we're going to do is we're going to go ahead and set our derivative, which is 8x to the third power, and we're going to set that equal to 1/8 because we're looking for the x coordinate. Here we're going to divide both sides by 8. Divide this side by 8. This cancels out, and you're going to get x to the third is equal to 1/64. The opposite of finding the cube power, the opposite of that is finding the cube root. So we're going to find the cube root of this side as well. So how do I do that in my calculator? I'm definitely going to show you this part. So the cube root is math. Cube root is option number 4. Okay, option number 5 is any root. Since I'm looking for the cube root, I can just hit that, and I can do 1/64. So alpha y equals 1 on top, 64 on the bottom. Right, 1/4. So x is equal to 1/4, which makes sense because 4 times 4 times 4 is 64. Okay, so x is equal to 1/4. Good. There are our last 3 points on this question. All right, this should be getting kind of repetitive. Oh, our last question. Oh, that was quick. So we have the equation of a curve is equal to da da da. And the next thing that we're going to do is we're going to find the equation of the tangent to the curve. Before we can do that, let's go ahead and find out what y is going to equal. So if x equals 3, we're going to plug a 3 in here. 9 divided by 3 is 3. 1 minus 3 is equal to negative 2. So y is going to equal negative 2. So we definitely need that. The next thing we're going to do is, so we know that the tangent passes through that point. 3, -2. The next thing we're going to do is we're going to find the derivative, okay, of our original function right here. So let's go ahead and write what this is. So this is going to be the same thing as 1 minus 9x to the -1. So let's go ahead and find the derivative of that. So the derivative of that is going to be, right, this is a constant, so that goes away. -1 times -9 is equal to +9. So this is going to be x, and then I'm going to subtract 1 from that, which is going to be -2. So my derivative is going to be the same thing as 9 over x squared. Okay, so at this point, I'm going to go ahead and substitute the number 3 in, right, because I know x is equal to 3. So if I plug 3 in for my x right here, right, my y prime of 3 is going to equal 9 over 3 squared. 3 squared is 9. 9 divided by 9 is equal to 1. Okay, so I know my gradient at that point. So my slope is equal to 1. Let me just go ahead and write that down. M is equal to 1. And the last thing I want to do is go ahead and plug it into my form, which is y equals mx plus b, or plus c. So I'm plugging in my numbers that I got here. So I have y is equal to -2. So -2 is equal to, my m is 1. Remember, we're not doing the normal, so you're going to leave 1. Our x is equal to 3 plus c or b, whichever one you'd like to call it. 1 times 3 is 3. Subtract 3 from both sides, and you get -5 is equal to c. So now let's put the whole answer together. So this is the answer for part A. I get y is equal to, my m is 1, so 1x plus c, which is -5. So that's my answer to A. For part B, the next thing we're going to do is go ahead and, it says find the coordinates of the point on the curve where the gradient is 1/4. So this is part B. So I have the point where the gradient is 1/4. So I have my derivative, which is right here, right? So I know that dy dx, or y prime, is equal to 9 over x squared. And they're telling us that the gradient is 1/4, so this is equal to 1/4. And I'm looking to find out what x is. So I'm going to cross multiply here. 9 times 4 is equal to 36. 1 times x squared is equal to x squared. The opposite of squaring something is finding the square root. So I'm going to find the square root of 36. So I get x is equal to positive and -6. Okay. So I'm looking for the coordinates. So one of the x's is +6, the other one is -6. So to find out what the y's are, I'm just going to go ahead and plug it into my function, right? I'm going to plug 6 in here. So I have 1 minus 9 over 6, right? I can go ahead and use my calculator for this. I know I don't need to, but 1 minus 9 over 6, so alpha y equals, option number 1, 9 over 6 is equal to -1/2. So 6, right? If I plug in 6, I get 6 comma -1/2. And if I plug in -6, so if I go, I'm going to be lazy here. And if I go right here, I'm going to insert a negative sign. So second insert -6 and plug that in, and I get 5/2. So -6 comma 5/2 are my two coordinates. Done.